Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is a part 5 video on the chapter of integers where I will discuss about the properties of closure, commutativity, associativity of integers under the operation of addition and subtraction, and finally we will solve 6 example problems. If you have not watched the previous videos, part 1 to part 4 on this chapter of integers, then I strongly suggest and request that you please watch those videos also to maintain the continuity of your study on the chapter of integers. This video is part of the playlist ICSE Math 7 following the textbook of author Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 5 video on the chapter of integers, where I will discuss about properties of closure, commutativity, associativity under addition and subtraction. Okay, so as a reference I have my quick notes on today's video on the left hand side. On the right hand side I will do the discussion and solve the example problems. Okay, so first of all let's understand the properties of addition of integers. We will discuss about 3 properties which are closure, commutativity and associativity. Now what is closure property? Closure property says that closure property of any operation, particularly since we are discussing about properties of addition of integers, so what does it mean by the closure property of addition of integers? It means that for any two integer a and b, a plus b, the result of a plus b or the sum of a plus b will also an integer. That is, integers are closed under addition. The closure property of addition of integers says that the integers are closed under addition. I think it is a very simple concept. There is nothing. There is nothing too much to think about the fact that a plus b. If when a and b are any two integers, then a plus b will also an integer. But if you want an explanation, maybe I can give an explanation. Is that to be assured that a plus b will also an integer. So let's think about the number line. So this is the number line, O is the origin representing the number integer 0. Let's say we are having let's say a, this point a is representing the integer small a. Now what does a plus b means? A plus b implies moving b steps to the right of a on the number line. So a plus b is nothing but, since b is an integer, b could be positive or b could be negative. But now when I say a plus b moving b steps to the right of a on the number, definitely I mean on the number where b is greater than 0. B is greater than 0, or you can also say b is greater than equal to 0. So moving a plus b when b is a non-negative integer, that is b is greater than equal to 0, it means that I am moving b steps to the right of a on the number line. Now when you move a number of steps from a particular position on the number line which is represented by an integer, you will obviously land to another integer. So when I let's say this is 3. Now let's say so if this be 3, now if I add a plus 3, it means that I am moving to the right hand side. I am moving 3 steps to the right hand side from the position represented by the integer a. Similarly, this will be, now I can say this will be moving, if b is negative, this will mean b moving b steps to the now actually moving b steps to the right of a on the number line. Now if b is minus 6, then moving minus 6 steps, minus negative steps is meaningless. So I have to be more accurate, or to be more correct, I must say moving mod of b steps to the right of a on the number where b is greater than or equal to 0. Now if b is a negative integer, suppose if we were doing a minus 6, then it basically means we are moving 6 steps. Now where is 6? Where is 6 coming from? 6 is nothing but absolute value of minus 6. So we are moving 6 steps to the left of a. So if b is negative, we must say moving b steps to the left of a on the number line. So there must be a number line. So on the number line where b is less than 0. So whenever you add some integer to another integer, when you are adding b to the integer a, now depending on what actually it is happening on the number line. So on the number line, if b is positive, then you are moving b number of steps to the right hand side on the number line from the point represented by a. And if you move certain steps either to the right or to the left from an integer, you will obviously land to another integer. So this is one way I can explain the fact that for any two integer a plus b, any two integer a and b, a plus b will also be an integer. So we say that addition of integers is closed, that is integers are closed under addition. Okay, so that was closure property. Let's see commutativity. Now what is the property of commutativity? We say that addition is commutative. It means that for any two integers a and b, a plus b will be equal to b plus a. It is very true that 2 plus 3 is equal to 5, which is also equal to 3 plus 2. You take any two integer, let's say minus 3 plus 1 is equal to minus 2. This is also equals to 1 plus minus 3. This is very obvious. So we say that addition operation is commutative. That is, for any two integer a and b, a plus b will be equal to b plus a. So that is the property of commutativity. Next is the property of associativity. The properties of associativity says that the property of associativity of integers under addition says that if abc are any three integers, then we will have a plus b plus c is equal to a plus b. You first add a plus b and then you add c to the result of a plus b. It will be equal to the result if you add first b plus c, if you add b and c first, and then the result you add it to a. So if this property is known as associativity, and which is satisfied by the addition operation. So obviously we always have, let's say, minus 2. Let's say we are doing the addition of minus 2 plus 3 plus minus 6. So we are adding three integers. The integers are minus 2, 3 and minus 6. So this will be equal to, I will first add the first two integers, that is minus 2 plus 3, and then I will add whatever the result will be of the addition of minus 2 and plus 3. With that I will add minus 6. Now what is the result of minus 2 plus 3? It is 1. So I have 1 plus minus 6, which is equal to minus 5. So minus 5 is the result when I added minus 2 and 3 first, and then I added minus 6 to the result. Now this will now if I add the last two integers, the second and third integers, and add that result to the first one, it should also give the same result, minus 5. Let's see, if I add first the 3 and minus 3, that is I am adding 3 plus minus 6 first, this is equal to minus 2 plus 3 plus minus 6 is minus 3. This is minus 3, and obviously this is equal to minus 2 plus minus 3 is minus of 2 plus 3, which is equal to minus 1. We get the same result. So so the addition operation of three integers, when we are adding three integers a, b and c, then the result will be the same if I add the first two and then add the third one, or if I add the last two and then add the first one, the result will be same. So this is we say that the addition operation of integers satisfies is associative, or satisfies the property of associativity. Okay, now we need to understand about these three properties regarding the subtraction of integers. So now we understand the properties of the same properties regarding under subtraction of integers. Okay, so closure property. So subtraction of integers is also closed, which means that integers are closed under subtraction, which means that if there are two integers a and b, the result of the subtraction of a and b, that is a minus b, it will also be an integer. Now the justification, you can consider the same justification as I did for a plus b related regarding the number line. I already explained the a plus b, and if it is so the subtraction a minus b, when we are doing subtraction a minus b, when we are doing subtraction a minus b, it means that we are now depending on whether b is positive. If b is positive, then we are moving b steps to the left of a on the number line, and if b is negative, then we are moving to the right side. How many steps? Absolute value of b steps to the right hand side. So considering how subtraction and addition of two integers works on the number line, you can easily justify that the subtraction and addition operation is closed. That is, when you add, that is addition of two integers a and b, the result will also be an integer, and also the subtraction of two integers, the result, that is will also be an integer. So subtraction of integers is closed, or we say integers are closed under subtraction. Let's see what about the commutativity. Now subtraction is not commutative, that is, for any two integers and a and b, if you take any two integers a and b, it is not the case that a minus b will be equal to b minus a. If it was commutative, if subtraction was commutative, then we should get then it should be true that a minus b is equal to b minus a. But for any two integers, it is not true. For example, if you take a and b as two different integers, let's say 3, let's say if I am doing 3 minus 2, this is equal to 1, but 2 minus 3, this is equal to minus 1, and this is not equals to 1. So clearly we see that for the integers 3 and 2, the subtraction is not commutative. You take any two, if you consider the integers a and b, any two integers a and b, and they are not same, they are different, then it will never be the case that a minus b is equal to b minus a. A minus b will always be not equal to b minus a when a and b are different integers. Now noteworthy, please note that the subtraction of two integers will be commutative only if a is equal to b. Why? When a is equal to b, let's say a and b is equal to let a is equal to b is equal to 1. So this implies that a minus b is equal to 1 minus 1 is equal to 0. Also b minus a is equal to 1 minus 1 is equal to 0. So we see that if for integer a is a equal to b is equal to 1, the subtraction is commutative. Now it need for if this will be true, the subtraction of two integers will be commutative if you consider any two integers integers a and b where a is equal to b. So this thing you must keep in mind. In general, we say that subtraction is not commutative. That is, for any two integer, it is not true that a minus b is equal to b minus a. Okay, let's see associativity. The subtraction of integers is also not associative. That is, we say integers cannot be subtracted in any order. Now remember that the associativity of addition, it also means that integers can be added in any order. In any order, it means that I can first add a plus b and then add c to it, or I can add first b plus c and add a to it. This is what it means by order of adding the integers. Now this will not be true for subtraction. You cannot subtract three integers in any order. That is, if you are doing subtraction of three integers a, b and c, that is, if I am doing, let's say a, b, c are three integers. If I have to compute a minus b minus c, this a minus b minus c is actually a, I can say it, a minus b and minus c, but this is not equal to a minus b minus c. That is, when I have to compute a minus b minus c, the result will be same if I compute first a minus b and then whatever the result of a minus b will be, I will subtract c from it. That is fine, but I cannot compute, I mean the value of a minus b minus c will not be the same if I first compute b minus c and then that result I will subtract from a. It will be different. That is, in general, we cannot say that a minus b and a minus b, this one is equal to a minus b minus c. In general, these two will not be equal. But one thing to keep in mind, that the associativity operation of subtraction of three integers will be the subtraction of three integers a, b and c will be associative only if c is 0. That is, if I am doing, let's say a, b, c are three integers where c is 0, then we can say that this subtraction operation, if we consider c to be 0, this will obviously be equal to a. I am doing first doing the subtraction of a minus b first and then subtracting 0 from the result. This will also be equal to if I first do the subtraction of b minus 0 and then the result of b minus 0, I will subtract that from a. It will be same. These two will be same only if c is equal to 0. So when I am subtracting three integers a, b and c, then it will be associative only when c is equal to 0. As you can see, a minus b minus 0 is equal to a minus b minus 0, which is also equal to a minus b minus 0. So this thing you must keep in mind. So subtraction of integers in general is not associative, but only for the case if of c, when c is equal to 0, then we can say that the subtraction of the three integers a, b and c, that is a, b and 0, will be associative. Okay, so this was all about the concept of the three properties: closure property, commutativity and associativity of the two operation addition and subtraction of integers. That is, both addition and subtraction are closed. Integers are closed under both the operation of addition and subtraction. That is, addition of two integers also give an integer, and subtraction of any two integer also give an integer. Commutativity, addition is commutative, but subtraction is not commutative. That is, for any two integer a and b, a plus b is equal to b plus a, but a plus b e will always be equal to b plus a for any two integer a and b. But in general, for any two integer a and b, it is not true that a minus b will be equal to b minus a. Only for the case of when a is equal to b, we will have a minus b is equal to b minus a. Associativity, the addition operation is associative. That is, we can add three integers in any order. That is, first we can add the first two integer and then add the third one, or we can add the last two integer and then add the first one. But this is not true in general for subtraction. So subtraction is not associative, but addition operation is associative. Subtraction operation will be associative only when c is equal to 0. Okay. The next two concept is about a general strategy to solve two kind of problem. The first one is that how do we find a pair of integers a and b such that a plus b is equal to k, where k is a known integer. It is given. So we have to find a pair of integers a and b such that their sum is k. So the steps or the idea is that you take any integer d which is not equal to 0. Now this k, a plus b equals to k, possibly k will not be a 0. I mean, even if it is 0, the steps will also work. So you consider any integer of your choice, but that should not be equal to 0. Let's say that integer be d. Then the two integers that we need to find, that is a and b, you can consider a as k minus d. K is given, k is a given integer, and the other integer b will be d. So so k minus d and d will be the required pair of integers. As you can see, so if you have a, we have to find two integer a and b such that a plus b is equal to, for example, let's say a plus b is equal to minus 9. I'm taking an example. So how do I find a pair of integer a and b such that a plus b is equal to minus 9? So what will I do? I will take any integer d of my choice which is not equal to 0. So let d is equal to 2. You can take any other integer value. So now the integers a and b will be, I can say a will be k minus d. What is k? K is minus 9. So minus 9 minus 2, and b will be equal to 2. That is, a is equal to minus 11 and b is equal to 2. You see, their sum is minus 9. You can consider for finding a pair of integer a and b such that their sum is minus 9, you can also consider any integer d to be any other integer. Let's say if I take d equals to minus 4, you can take any integer, it does not matter. It is preferable that you don't take 0. Now, so what will a be? A will be so a, you can consider a to be k minus, so a will be k minus d. What is k here? K is minus 9. Minus 9 minus d was minus 4. This which is equal to minus 9 plus 4, which is equal to minus 5. So a is minus 5 and b will be equal to minus 4. You see, minus 5 plus minus 4 is minus 9. Okay. Now there is a point to note that if you are asked to find a pair of integer a and b where the sum of a plus b is given to be a known integer, which in the note is referred as k, then there can be, there are infinite number of possibilities of such pairs. So one such, for if a plus b is given as minus 9, one such pair can be a is minus 11 and b is 2. Another pair can be a is minus 5 and b is minus 4. This way there are infinite possibility of this kind of pairs of numbers a and b whose sum will be minus 9. This thing you must keep in mind. Okay, the next kind of problem to solve is that finding a pair of integer a and b which are additive inverse of each other such that their difference, that is a minus b, is equal to k, where k is a given integer, and it is an even integer. Now remember that k is even integer, it could be positive even like 4, 6, 8, or k can be a negative integer like -2, -4, -10, like that, but k will be an even integer, that is k will be divisible by 2. So how do we find such pair of integer a and b from k? Note that a and b are additive inverse of each other and their difference is given, that is a minus b. It is given that a minus b is some k, some integer, some even integer. So how do I find a and b? So the steps are, you will find first the value of, let's say I am taking an example, let's say a and b are, it is given a and b are two integers which are additive inverse of each other, and it is given that a minus b is equal to, let's say 3. No, 3 cannot be because k must be an even integer. Let's say a minus b is equal to 4. So the first step, he says that d, you find d as absolute value of k, that is absolute value of 4 divided by 2. This is equal to, absolute value of 4 is 4, so 4 divided by 2 is equal to 2. So d is 2. Now please note that since k is an even integer, the absolute value of k divided by 2 will always be an integer. Okay. Now the next step is, now we can find a and b. You can consider a as d and b will be minus d. Since a and b are additive inverse of each other, if a is d, then b has to be minus d. Now in this problem, d we have found to be 2. So a is 2 and b is minus 2. So 2 and minus 2 are a pair of integer, which are obviously additive inverse of each other, and their difference is 4. Now remember, it is given that a minus b is equal to 4. So we are having a is equal to 2 and b is equal to minus 2. If it was given that b minus a is equal to 4, then we would have got a is equal to minus 2 and b is equal to 2. So this is important. Let's take another example. Let's say now this k, as I said, is an even integer. It could be positive even integer or it could be negative even integer. Let's say a, it is given, let's say a and b are two integers which are additive inverse of each other, such that it is given such that the difference, that is b minus a, is equal to minus 6. Obviously minus 6 is divisible by 2. So k in this example is minus 6. So we have to now find what will be the value of a and b. Okay. So as per the steps, first compute d, that will be absolute value of k by 2, which is absolute value of minus 6 by 2. This is equal to 6 by 2, which is equal to 3. Now b will be equal to, remember this time b will be equal to d, which is equal to 3, and a will be equals to minus d, which is equal to minus 3. If we are given a minus b is equal to k, then we will say that a is equal to d. But if we are given b minus a is equal to k, then we will say b is equal to d and a is equal to minus d. You can verify that 3 and minus 3 are obviously additive inverse of each other, and you will see that b minus a is equal to minus 6. B minus a, no, b minus a is coming out to be 6. It is not coming out to be minus 6. I did some mistake. 1 second. I think the problem statement will be that a and b are two integers which are additive inverse of each other, and their difference is k. It will not be specifically said whether a minus b is equal to k or b minus a is equal to k. If I consider a is equal to d, d is coming out to be 3. So a is equal to 3 and b is equal to, if I consider over here if I consider over here, after finding D, which is 3, if I consider that A is equal to D, which is 3, and B is equal to minus D, which is minus 3, then what will be B minus A? B minus A will be minus 6. Okay, so A will always be D, and B will always be minus D. So irrespective of whether it is given A minus B is equal to K or B minus A is equal to K, you first find the absolute you first find D, which is absolute value of K divided by 2, which in this problem is 3, where it is given that B minus A is equal to minus 6, K is minus 6, so D is 3. Now A will be D and B will be minus D. So always remember that irrespective of whether it is given A minus B is equal to K or B minus A is equal to K, always set the value of A to be D and the value of B to be minus D. Okay, now one thing to note is that there is only one pair of integers A and B which are additive inverse of each other and whose sum is a given integer, given even integer. By that I mean, if it is said that find the integer A and B which are additive inverse of each other and their difference is minus 6, then the two integers has to be 3 and minus 3. The two integers has to be 3 and minus 3. There cannot be any other two integers which are additive inverse of each other whose difference will be minus 6. Similarly, in the case where it is given A minus B is equal to 4, the two integers A minus B, the A and B has to be 2 and minus 2. So as per the notes, there is only a single pair of integers A and B which are additive inverse of each other, such that A minus B is equal to K. So when you are asked that find two integers A and B which are additive inverse of each other and the difference is some even integer K, then always remember that there will be only one unique pair of integer A and B. So this is all about the concepts of in this video regarding the closure, regarding the properties of closure, commutativity, associativity of addition and subtraction of integers, and to a specific problem like finding a pair of integers A and B such that their sum is a given integer, and finding a pair of integer A and B which are additive inverse of each other such that their difference is a given even integer. Based on this concept, now let's try to solve example problems. Now, as always, I said that whenever I am solving example problems, always try to solve the problems yourself first. That is, pause the video, solve the problems, write the answers, and then match your answers with my solution. But please do watch my solution because I might give some important information while solving the problem. Okay. So the first problem is question number 1. It says that which of the following correctly shows the commutative property of addition of integers? Okay, some operation is given, some equality, some equation or statement is given, and we have to say which one of the choices correctly demonstrates the commutativity, the commutative property of addition of integers. We know that the commutative property of addition of two integers A and B says that A plus B is equal to B plus A. Now let's see the choice A. The left hand side is plus 3 plus minus 2. That is, we are adding minus 2 and plus 3. Plus 3 and minus 2 are the two integers. Now if this to demonstrate the commutative property of addition on these two integers plus 3 and minus 2, I must write that this must be equal to minus 2 plus 3. This is the correct way of demonstrating the commutative property of addition on the two integers plus 3 and minus 2. Now I cannot now, so but on the choice A on the right hand side it is minus 2 plus 3. Even though the value of minus 2 plus 3 is 1, and also the value of the left hand side is 1, but still it is incorrectly demonstrating, it is not correctly demonstrating the commutative property of integers of addition under addition. So A is, this is incorrect. Let's see B. On the left hand side it is given that -2 plus 5. So what we are adding, this is equal to, we are basically adding -2 and the integer 5. Now if we want to demonstrate the commutative property of addition of the two integers -2 plus 5, on the equality on the right hand side it must be 5 plus -2, but on the right hand side of B you can see it is written as 5 minus 2. 5 minus 2 is not an addition operation at all, it is a subtraction operation. So this is also not correct. Choice C. On the left hand side it is -6 plus 7. Now, so on the right hand side, to demonstrate the commutative property of addition of two integers -6 and plus 7, I must have 7 plus -6, and on the right hand side of C it is indeed 7 plus -6. So this is the correct demonstration of commutative property of two integers. Also you can check D, it will be wrong, as 9 plus 3. If I want to demonstrate commutative property of addition on the two integer 9 plus -3, on the right hand side it must be -3 plus 9, but on the right hand side of choice D it is given as 6. So choice D is also incorrect. So definitely the answer is, correct answer is C, choice C. Okay, let's see question number 2. Which of the following correctly shows the associative property of addition of integers? Okay, so it's a similar question like one, but this time we have to find which is the correct demonstration of associative property of addition. Okay, the first one, A is given as minus A plus B plus minus C. Now if I want to demonstrate correctly the associative property of addition of the integers, so what are the integers here which are involved? It is minus, so this is equal to nothing but, I can say minus A is minus A plus B. So we are first adding B and minus A, and then we are adding minus C. So the as per associative rule, associative property of addition, this must be equal to, I must say this must be equal to, I will add first B and C and then the result I will add to minus A. So this must be equal to minus A plus B plus minus C. This is the correct demonstration of associative property of addition. But in the choice A, on the right hand side you see it is a different thing. It is minus A plus B minus C. Now B minus C is not even an addition operation, it is a subtraction operation. Even though B plus minus C is equal to B minus C, but to demonstrate the associative property I cannot write B plus minus C as B minus C. So A is a wrong, incorrectly, A is incorrectly demonstrating the associative property. Let's see choice B. The left hand side is x plus minus y plus minus z. Now on the right hand side, so first it is on the left hand side it is first adding the, okay, so first of all what are the integers we are adding? What are the three integers we are adding? They are x and minus y and minus z. So on the left hand side it is first adding the first two integers, that is x and minus y. So on the right hand side I must first add minus y and minus z and then add x to it. So on the right hand side I must have x plus and then minus y plus minus z. This is the correct demonstration of adding the three integers x, minus y and minus z to show the associative property of addition. But in the choice B you can see the right hand side is a different thing. Even though the right hand side of choice B evaluate or simplify to the same value, but it is not correctly demonstrating the associative property. So choice B is also incorrect. Let's see choice C. On the left hand side, we are having minus P plus Q plus R. So this is nothing but, we can say, minus the three integers are minus P, Q and R. So for in this first we are adding the first two integers, which are minus P and Q, and then we are adding R to it. So to demonstrate the associative property on the right hand side, we must add the last two integer, that is Q and R, and then add minus P. So it must be minus P plus Q plus R. But in C, you see in C it is a completely different thing. Even though the value will come out to be the same, but it is incorrectly written. It is incorrectly written. So choice C is also a incorrect demonstration of associative property of addition. So obviously choice D has to be the correct answer, but anyway, let's check it. So we have U plus minus V plus minus W. So the three integers are U, minus V and minus W. So it is given that, so if I now add as per the associative property of addition, I can add the first two, that is U plus minus V, and then add minus W, or I can add the last two. I can add the last two and then add U. So this is the correct demonstration of associative property of addition of the three integers U, minus V and minus W, and you can see D is correctly showing that. So D is the correct demonstration of associative property of the integers. Okay, so the answer is choice D. Let's see question number 3. Subtraction of two integers A and B will be commutative only if. Now, so in the quick notes, I have already explained that the subtraction operation of two integers A minus B, it will be commutative, means A minus B will be equal to B minus A, implies that A has to be equal to B, or this will be true only if A is equal to B. So this is the condition. Subtracting two integers A and B will be commutative if the only condition is that A and B has to be the same integer. So what are the choices given? The choice A says that minus A and B are additive inverse of each other. Minus A and B are additive inverse of each other. Now if I have, so I know the only condition A minus B will be equal to B minus A is A is equal to B. Now does A equals to B mean that minus A and B are additive inverse of each other? Now let's see if minus A and B are additive inverse of each other, I must have their sum to be equal to 0, that is minus A plus B is equal to 0. I can see that this obviously implies that if I bring if I transpose minus A to the right hand side, I will get B is equal to A. So indeed A equals to B, and the fact that minus A and B are additive inverse of each other, they means the same thing. The only condition that A minus B will be equal to B minus A is A is equal to B. Now the fact that A is equal to B can also be said in a different way, that minus A and B are additive inverse of each other, because if minus A and B are additive inverse of each other, I can say that their addition is equal to 0. So you know that if two integers x and y, they are additive inverse of each other, we always have x plus y is equal to 0. So in this case, if minus A and B are additive inverse of each other, we must have minus A plus B is equal to 0, which means B is equal to A. So this is the correct choice. Now definitely B will be incorrect. Now what is C? A is equal to 0 and B equals to 0. No, it is not necessary that A and B has to be equal to 0. A and B can be any integer, but A should be equal to B. So C is not correct. And D says mod A is equal to absolute value of A must be equal to absolute value of B. Let's see. So let's see the choice D. It says that absolute value of A is equal to absolute value of B. Now we know that we must have A is equal to B. Now A is equal to B, and does it mean that absolute value of A will be equal to absolute value of B? By that I mean that these two statements, A is equal to B and absolute value of A is equal to absolute value of B, are these two the identical statement? That is it the fact that absolute value of A is equal to absolute value of B means that A is equal to B? We must verify that. If absolute value of A equals to absolute value of B, if this means that A is equal to B, then obviously D will also be a correct statement. But let's see. Now I already explained in the video of, I think in the first video, about the absolute value of integers. When we have something like this, that absolute value of x is equal to A, where A is a known non-negative integer, that is a any integer greater than or equal to 0, A is known, and we have to find x. What are the values of x such that absolute value of x will be equal to A? The values of x, we have discussed that x will be equal to plus minus A. That is, x can have the value of A, or x can be equal to minus A. Both the value A and minus A will satisfy the equation that absolute value of x will be equal to A. So in this problem, absolute value of A is equal to absolute value of B. This will imply that A is equal to absolute value of B, or A is equal to negative of absolute value of B. Now absolute value of B is always a positive integer. So I can say this statement, from this statement, this implies that A is equal to B, or A is equal to minus B. Now, so D, the choice D, the fact that absolute value of A is equal to absolute value of B, this implies that the value of A can be B or minus B, but A cannot be minus B. If A is minus B, then we will not have A minus B is equal to B minus A. You can see, but if A is equal to minus B, this will imply that A minus B will be equal to minus B, which is equal to minus twice B, and B minus A will be equal to B minus B, which is B plus B, which is twice B, and minus twice B is not equals to twice B. So definitely, if A is equal to minus B, then we will not have that A minus B is equal to B minus A. So we must have A is equal to B. We cannot have A is equal to minus B. And D, the statement D, which is saying that absolute value of A is equal to absolute value of B, this means that A can have the value of A can have the value of B or minus B. But if A is minus B, it will not satisfy the fact that A minus B is equal to B minus A. So D is incorrect. So definitely choice A, answer A, the correct choice is A. The only condition is that A equals to B, and A equals to B also means that minus A and B are additive inverse of each other. Okay, let's see question number 4. It says that P, Q, R, X, Y and Z are integers where P is equal to X plus Y, Q is equal to Y plus Z, and R is equal to P minus Q. Okay, then subtraction of integers P, Q, R will be associative as below only if So subtraction of integers p, q, r will be associative as below. So we know that if subtraction of the three integers p, q, r are associative, we must have p minus q. We can first subtract. We can do first p minus q and then subtract r from the result. That is, subtraction has to be associative on the integers p, q, and r. So we must have p minus q minus r should be equal to p minus q minus r, or this should be equal to p minus q minus r. So in the problem it is saying that then subtraction of integers p, q, r will be associative as below only if. So we have to find the condition. When the subtraction of the integers p, q, r will be associative, which means that we will have this equal to this. Now p, q, r we know is has been defined in terms of x and y and z. So we know that it is p, given that p is equal to x plus y. Okay, before that, fine, let's write it down. Q is equal to y plus z and r is equal to p minus q. Now when do we say we have just studied while discussing the associative property of subtraction? We know that subtraction of three integers a, b, and c, that is a minus b minus c will be associative. That is, this will be equal to a minus b minus c only if c is equal to 0. Only if c is equal to 0. Then only we can say that the subtraction of the integers, that the subtraction a minus b minus c will be associative. That is, a minus b and then minus c will be equal to a minus b minus c only if c is equal to 0. So we have to apply the same condition. It is given that what will be the condition so that the subtraction of the integers p, q, r will be associative. So definitely we must have r to be equal to 0. So this implies that r should be equal to 0. R is the c. R is the c. So r has to be equal to 0. Okay. Now what is r? R is nothing but r has to be equal to 0. Now what is r? R is p minus q. So this must be equal to 0. So this implies if p minus q equal to 0, we must have p is equal to q. This implies what is p? P is x plus y. X plus y. This must be equal to what is q? Q is y plus z. So this is the condition. X plus y is equal to y plus z. Now you see y is on both the side. I can cancel y from both the side. So this will imply x is equal to z. So this is the only condition where if x is equal to z, we will have pq. Then the subtraction of pqr, that is p minus q minus r, will be associative. That is p minus q. This will be equal to this. The condition is initially the condition was that we know that a minus b minus c is equal to a minus b minus c only when c is equal to 0. So in the case of pqr, if we must have p minus q and then minus r is equal to p minus q minus r, then we know that r has to be 0. So r is 0, which means that r is 0. So which means that r is what? R is p minus q. So this means that p minus q is 0, which means that p equals to 0. P is equal to q. Now what is p? P is x plus y. So we have x plus y is equal to y plus z. Now from the equation x plus y is equal to y plus z, I can easily cancel out the same term from both the side, which is y. I can cancel out y. So I have x is equal to z. So this is the condition. This is the required condition, and hence the correct choice is B. The correct choice is B. Okay. Let's see question number 5. Let integers p and q are additive inverse of each other such that p minus q is equal to minus 8. Then the value of minus p plus 2q is. Okay. So it is given that p and q are additive inverse of each other and the difference is minus 8. So difference is minus 8 means the k is minus 8. Okay. So so it is given that p minus q. So this is the problem of finding a pair of integers a and b where their difference is given to be k, where k is some even integer. In this problem k is minus 8. Obviously minus 8 is an even integer. Okay, so the step was we first find d as absolute value of k by 2, which is absolute value of a minus 8 by 2. This is 8 by 2. This is 4. So now I will say that p is equal to a d, that is 4, and q is equal to minus 4. This was the steps to find the pair, the integers values, the integers p and q. Now clearly you can see that p minus q, if you always verify whether p minus q is coming. So obviously 4 and minus 4 are additive inverse of each other, that is fine, but I need also to verify that p minus q is coming out to be minus 8. So p minus q, as you can see, p minus q is coming out to be 4, but p minus q is coming out to be 4. Now I think p minus p will not be 4. P equals to 4 and q equals to minus 4 will not make p minus q is equal to minus 8. Since it is given p minus q is equal to okay, what was the concept? Then a equals to d and b equals to minus d. A equals to d. D is coming out to be 4, so a equals to d, a minus b. Now I think you need to be a little careful regarding which one. So after finding d, now when k is negative, if it is given that the p minus q is equal to minus 8, so d is definitely 4, that is fine, but whether p will be equal to 4 or p will be equal to minus 4, you have to be careful, because if I take p is equal to 4 and q is equal to minus 4, I am getting p minus q as 4 minus 4. This is equal to 4 plus 4, this is coming out to be 8, but it was given originally that p minus q is equal to minus of 8. So definitely p equals to 4 and q equals to minus 4 is the wrong assignment, wrong value. Actually it will be p will be equal to minus 4 and q will be equal to 4. So after finding d, you will obviously know that the two integers will be 4 and minus 4, but which one will be 4, whether p will be equal to 4 or q will be equal to 4, you have to decide that based on whether it is given p minus q is equal to, you have to use this fact. You have to manually check whether from d, that is from 4, whether you will assign p to 4 or q to 4. In this problem, p will be equal to minus 4 and q will be equals to 4. Then you will see that p minus q is coming out to be minus 8. So once you have found d will always be a positive integer. Once we have found d, then obviously the two integers will be d and minus d. Now since it is given p minus q is equal to minus 8, then you have to be careful whether you will assign d to p or d to q. Just doing a little bit of calculation, you can easily see that in this problem p has to be minus 4 and q will be equal to 4. Okay, fine. So what was the problem? So definitely P is equals to minus 4 and Q is equal to 4. Okay, so we have to find P minus, so this implies, so we have to find minus P plus 2Q. Now this is equal to minus P is minus of minus P is minus 4, so this is minus of minus 4 plus Q is 4, so this is this. Okay, this is equal to, I can say, minus of minus 4 and plus 2 into 4 is 8. This now negative of 4 is 4, so this is 4 plus 8, this is 12. So the value of minus P plus 2Q will be 12. So the correct answer choice is C. So please note that I did a mistake by solving. Initially I thought P will be equal to 4 and Q will be equal to minus 4. This is wrong. Definitely up to the step of finding D, that is fine. So D will obviously be absolute value of K by 2, and the two integers P and Q will be, the two integers will be definitely, one will be 4 and one will be minus 4, the other one will be minus 4. Now if it is given P minus Q is equal to minus 8, then you have to be very clear, you have to be careful whether P will be equal to 4 or P will be equal to minus 4. This you can do a little bit of trial and error and find it out. In this case, it is clear that P has to be minus 4 and Q has to be 4. Okay, let's do question number 6. Let there is a symbol triangle be an operation on integers defined as below. So a triangle B is equal to absolute value of A minus B, where A and B are integers. Then which of the following properties are satisfied by the operator? Closure property, commutativity, C is both A and B, and D is none of A and B. Okay, so a new operator has been defined with a triangle symbol, it is defined as A. This is the new operator, triangle symbol A, triangle B. It is defined as the absolute value of A minus B. Now, okay, so definitely, so this implies that if delta operator is commutative, then we must have A delta B should be equal to B delta A. So this implies we must have absolute value of A minus B is equal to absolute value of B minus A. So the delta operator will be commutative if this is satisfied for any two integer A and B. Now we need to check whether this is true or false, whether absolute value of A minus B is equal to absolute value of B minus A. Now absolute value of B minus A, if I take, so this is what? This is B minus A. I am subtracting A from B. Now I think you will understand if I take from B minus A, you have already done algebraic expressions, and you have already done how to do factorization of algebraic expression in class 6, I guess. Now okay, so B minus A I can so what is B minus A? B minus A is nothing but B plus minus A. So this is if I can write it as B minus A, I can, okay, so B minus A I can write it as, I hope you will understand, I can write it as negative of A minus B, negative of A minus B, because if you simplify this, negative of A minus B, what is this? So there is a negative sign in before the bracket. I hope you are familiar with the Bodman's rule, where if there is a negative sign in front of a bracket, we open the bracket, but all the terms inside the bracket their sign gets changed. So this will be minus A and plus B, which is nothing but B minus A. So B minus A can be written as minus of A minus B. Now absolute value of minus of A minus B is equal to absolute value of A minus B. As I have explained earlier while discussing absolute value, we always have absolute value of x is equal to absolute value of minus x, where x in this problem is a minus b. So absolute value of negative of minus of a minus b is equal to absolute value of a minus b, and you can see definitely so we can say that absolute value of b minus a is equal to absolute value of a minus b, which satisfies the commutative property. So definitely this operator, the triangle operator, is commutative. Now let's see whether it satisfies the closure property or not. Now what is so the new operator a triangle b is equal to absolute value of a minus b. Now we need to see whether the absolute value for any two integer a and b, whether absolute value of a minus b is an integer or not. Okay. Definitely absolute value of a minus b will be an integer. Why? A and b are integers. This will imply a minus b is an integer. Why? Because a subtraction operation is satisfies the closure property, that is integers are closed under subtraction. So if a and b are integers, we will always have a minus b is also an integer. So this will also imply that absolute value of a minus b is an integer, will also be an integer. Absolute value of any integer is always an integer. So finally we are getting that absolute value of a minus b is an integer. So we can say that absolute a triangle operator is also an integer, where a and b are integer. So definitely this new operator, triangle operator, is satisfying both the closure property and the commutativity property. So the answer is C, both a and b. Okay, so with this it brings to an end in the part 5 video on the chapter of integers, where I discussed about the properties of closure, commutativity and associativity of integers under addition and subtraction, and I discussed about a strategy of solving two specific kind of problem, that is finding a pair of integers a and b such that a plus b is equal to a given known integer, and how to find a pair of integer a and b which are additive inverse of each other such that the difference is equal to some integer, known integer, which will be even. And finally I solved 5 example problems. I hope this video will be beneficial to you in understanding the concepts discussed and how to apply the concepts to solve this kind of problem. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video I will solve probably the problems of exercise 1.2, and then I will move on to the next topic of multiplication of integers. So those videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.